Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering.
On this episode, Tristan and I sit down with Sarah Nagy, the CEO of Seek, and Chris Aberger, the CEO of NumberStation. The two of them are building companies that leverage generative AI to help with data work. Seek is focused on helping answer data questions, and NumberStation is helping automate data-intensive workflows from queries to predictions. In this conversation, we explore what is happening in the AI world with generative AI and foundation models, and we imagine how these breakthroughs will affect how companies work with data. This is a great primer for folks looking to get a lay of the land of what's happening on the forefront of AI innovation.
I tried really hard not to use this episode as just an excuse to ask experts in this area just all the questions that I've always had, because there's a lot of them. I do think that we got into some really good foundational stuff that makes it a very good primer on like what you need to know about large language models and their impacts on data. Like, remember that part of the episode when they were talking about when everything became a transformer model? I was just like, why did that happen? How does that work? And is it going to stay like, anyway, we'll have to have another episode on it like this, I think.
Yeah. I think you at the end said something to the effect of, is this already passé? Like, is everyone just only talking about this stuff nonstop? Should we even have an episode? And I disagree. I think this is still really new information for so many people. And what's hard is we don't get the opportunity to have these conversations with experts of like, what is a transformer model and what is a foundational model and how do you build on top of these things? So we got to go a little bit deeper and get to learn a bit more of the terminology that people pass around and assume that everyone has the same context for. So I think it's a really great episode. And without further ado, let's get into it.
I am very, very excited to talk to both of you folks today, Chris and Sarah. We are going to be talking about probably the most discussed topic in all of technology today. How do you take some of the technology and excitement around large language models and translate that into actual usable products? And in our case, usable products in the scope of data analysis. Before we dive in, Chris, why don't you go first? Say a little bit about who you are, what you build, where you've been.
Yeah, so my name's Chris Aberger. I'm currently a co-founder at NumberStation. Prior to NumberStation, was at another startup called Sambonova Systems, where we were pre-training a lot of these foundation models that we're going to talk about here today. And then before that was at Stanford doing my PhD on a mix of AI and data systems. And at a high level, exactly as you just alluded to, Tristan, what we're doing is applying this new technology wave of foundation models to various different problems in the data analysis space. And I'm sure we'll dive into that in more depth. That's a high level overview of my background.
Sarah, how about same questions?
Great. Yeah. Thanks so much for having me. So my name's Sarah Nagy. I am the co-founder of Seek AI. Prior to starting Seek, I came from the quantitative finance world here in New York. So started out as a quant on Wall Street doing algorithmic trading for a few years, led data teams at a couple B2B SaaS startups, and led a data team at Citadel. The pain point that Seek is working on solving is a pain point I personally experienced pretty much everywhere I worked as a data scientist, where as that kind of data person in the company, everyone kind of flocked to me with questions. And when I discovered what we now call generative AI, I realized we could solve a lot of those problems with code generation.
I know that even just in those intros, I feel like we've talked about generative AI, transformers, large language models, foundation models. There's a lot of new vocabulary in this space. I have been following, not as a practitioner, but as like a deeply interested party, the advances in deep learning from whenever it was, 2011? But there've been so many advances in that time period. I want to just get a snapshot of where we're at today. Where do you think it makes sense to kind of start? Let's just assume that listeners have some kind of rough background on deep learning more broadly. Can we kind of zoom in from there? Where are we at?
Well, I would say what's kind of interesting is, a few years ago, I remember this tweet. I don't know if you saw it, but it went kind of viral where someone was like, I feel like most executives at big companies think that AI is just doing a group by with SQL. And, we kind of had this period of time where I think no one really knew what AI was. And sometimes people were conflating it even with just big data analysis. So I think what's interesting about, where we've come today is when people say AI, now, they're talking more and more about this so-called generative AI, which is, I think it's kind of a catch-all for large language models, foundation models, I think even transformer models in a way. But at least it's real AI in the sense that it's the most state of the art, and people aren't mistaking it for something else like big data analysis. What it really means is just very large models with billions and billions. Now it's kind of broaching trillions of parameters that can actually oftentimes take natural language. And when people say generative, just colloquially, it's because it's generating stuff, language, images, code, whatever you tell it to generate in the natural language interface.
Yeah, and just to riff off of what Sarah's saying here, it's really interesting to see how we got to this point in generative AI where we are generating these things like images and text. And, if we go back to when I was actually doing my PhD at Stanford, the world was quite different, right? At that time, most AI researchers were actually looking at selecting across a bunch of different models, and they weren't centered on a single model architecture.
So it's ensembles.
Well, no, not so much ensembles. It was more like if I wanted to do something in the image space, I was using convolutional neural networks.
Yes.
And actually in the language space, the state of the art at the time was sequence-to-sequence models. So these recursive models like RNNs or LSTMs. The models themselves aren't important, but an important thing that happened around 2017, 2018 were these transformer architectures that came out, which is really the basis of everything that these foundation models or even generative AI models are built off of. So these just use a mechanism called attention. And the interesting thing here was it was really efficient to run on GPUs. They kind of took off and took over the landscape, and the ML community all collapsed in around 2018 to basically running around this architecture for a lot of different things. For foundation models, the interesting thing that happened here was this technique called self-supervision. So basically what this enabled was large-scale training across internet-scale data where humans didn't have to go in and manually annotate the data that they were training on. They could just train over data sets that you'd feed into it. And so this enabled these training of really, really large models on these platforms that learned basically all the content that there is out there today and led to this trend in generative AI. So it's a really fascinating time in that the ML community is all centered around these transformer architectures, more or less right now. And these foundation models are just trained on basically all the data that's out there and doesn't require any human input in that training process.
So we probably should have done this a minute ago because I think we've used the word transformer and foundation at least a dozen times each. But do you want to just take a minute to describe what those specifically mean? I think the terms can often get conflated too, and also large language models. Is that just a subset of a foundation model, or how do you think about it?
Transformers are that architecture piece. So it uses a mechanism called attention underneath, which basically allows you just to attend to certain parts of the data that you're feeding underneath. So it's really the mathematical component or backbone of these architectures.
Was this a Google research paper?
Yeah, so it's called Attention is All You Need. It was a really popular, actually provocative paper at the time. I remember when it came out, a lot of the ML community was split. Like, is that true? No, like we're still using LSTMs. It might not actually be the case. Turned out to pretty much be true and what we're seeing right now. But yes, that's exactly the paper that kind of ushered this transformer architecture in. Foundation models, this term was actually popularized by a Stanford lab that came out, and actually some of our co-founders were a part of popularizing this term. But basically, foundation models are these models, largely usually transformers are powering what's running underneath, but they're fed just a large amount of data on a single backbone and are able to run a variety of different tasks. So this can just be text generation. It could be image generation. It can apply to a wide variety of tasks because it's trained on this internet scale data that they have being fed into it.
So it feels like we have this recent new excitement around foundation models and generative AI, which really started last year. And I think it has a lot to do with people, everyday people who just are interested in the internet can actually test out these technologies. They get to play around with ChatGPT, get to make really cool art with DALL-E. Are we actually seeing a different growth spurt in AI right now in 2022 and hopefully carrying on into 2023? Or is this really just a continuation of what we've been seeing since, the last several years, but now consumers are getting their hands on it?
Well, what I think is kind of interesting is that GPT-3 is not that new. It actually came out almost 3 years ago, which is pretty amazing. And before that, there was even GPT-2, which, if you recall, OpenAI was like, we don't want anyone to work with this. It could be dangerous.
It's so powerful that we can't release it.
Right. But I do think, thinking back to, just when you use like Alexa or Siri, they are pretty limited in what they can do. And I think that type of technology is what people were used to before DALL-E came out and then ChatGPT came out. So I think a lot of the excitement is just, this is a step function in the quality of the responses to the natural language inputs. And I think because the quality is just so much better, and I mean, it's like, for all intensive purposes, it's basically passing the Turing test. And you can't say that about Siri or Alexa, at least, the ones that we're used to right now. So I think that's what, the public noticed that, and that's what caused this to really take off.
That delay between releasing GPT-3 and the popularization of ChatGPT, which was November 22. Do either of you have thoughts? I understand you don't work for OpenAI. You're not in their all hands meetings, but was there actual technical work to be done there that would allow you to turn this foundation model into something that could be kind of widely used? Or was it just that there hadn't been this moment where it had reached kind of mass awareness?
Yeah, so this is, of course, speculation and just
of course.
things I've heard. But what I've heard that they were doing a lot of over the couple of years is actually talked a little bit about that self-supervision, right? Where you can just feed in the data and the model's trained. What I've heard and what's been speculated is actually they were doing a fair amount of fine-tuning, right? Where they had human annotators actually going in and saying, this is a good response, this is a bad response, and then using other techniques called reinforcement learning to basically go back and improve these models for chat-like interfaces over time. And so that led to, this, what they're calling like GPT 3.5, which is effectively ChatGPT that's been released. Of course, this is all speculation. I don't know the internals of what's actually going on at OpenAI, but I've heard that there's been a fair amount of that actually going on with human annotators going in and making these models much, much better.
But more broadly, there is work to be done between a large language model and maybe a version of that model that could be usefully productized in a given context. Just because you have this foundational model, it doesn't necessarily translate directly into fitness for purpose for a given use case. Is that a lesson to be drawn from this?
Yeah, I think that's one of them. I think another interesting thing to look at here, right, is they're more like looking at solving AGI, right, like OpenAI with these style problems. So it's generally learning a lot of things. But if you want to go apply that to a specific thing that you want to run in production, whether it's some, data analysis technique or what have you in a given enterprise, it's not clear why I would need the knowledge from, GPT that can generate a poem or a recipe for cooking. I really wanted to specialize to a particular enterprise use case and the data within that enterprise. And so there's this whole host of last mile problems to go from basically these large models that you can start from that get you to, let's say, a 60 or 70% solution, for what an enterprise really needs is a 90% solution. And to get back to what you just brought up there, Tristan, what we found and what we do a lot of internally is fine tuning and specialization of much smaller foundation models for these enterprise use cases. You don't actually want to just go in with the large, GPT-3 model. There's economic implications to that, but also there's quality implications in terms of how well it can actually personalize to a given enterprise.
Economic implications like it just costs a shit ton more training.
Yeah, it's 170. Well, just the scale that you think about the hardware to just host a 175 billion parameter model, how much it costs just to run an inference on that, and also how quickly you can get responses back. And also there's a whole other host of issues in terms of passing MRM. It's a black box API call. enterprises typically want to own the model weights and know how it was trained and apply personalized model to their given enterprise problems.
Are startups like NumberStation and Seek, are you using these foundation models that are trained on lots of data, most of which is not useful for your specific use case of what you're trying to solve, which is data within enterprises? Do you still first start with these large foundation models and then fine tune them, or do you have to start from scratch?
We use foundation models that were pre-trained. Like Chris was saying, these models, they know a lot of stuff that may not necessarily be relevant, like recipes and things like that. But that kind of knowledge is actually really helpful when both of us are applying these models to data applications within enterprises. And let me think of an example for a recipe, for example. Say that you're a B2C tech company and recipes or food, say your food delivery, for example. That knowledge of recipes, like that broad knowledge of just the food universe, for example, could be relevant, or if you're like what we encounter is sometimes our customers have all sorts of different data sets, and there might be one column that has something that's adjacent to food, that maybe the rest of the business and the rest of the data doesn't contain anything like that. That broad knowledge of the foundation model is what actually helps it perform so well. And before these models existed, if you were just, training from scratch a small model only on very, very specific data for a certain domain, it would miss a lot of these kind of fuzzy areas that are outside the domain.
Yeah, I agree with Sarah 100%. And there's not a lot of need to reinvent the wheel, right? And think about how expensive it is to just pre-train these models from scratch and how much OpenAI and other companies have put into this. So it's a great starting point, right? And we like to start off of these models. But the way I always think of it is it gets you 60 to 70% of the way there. And you usually need to bring in some other techniques, usually fine tuning, to get you to that last kind of 90 to 95% where it's acceptable to actually deploy in the enterprise setting.
So as I understand it, there are 2, maybe 3 solutions out there that can help you with these pre-trained foundation models. You can go to models from Google. There's OpenAI, and Anthropic is maybe the third team that spun out of OpenAI that's also doing something similar. Are there more options than that, or is it really limited to if you need a big foundational model, you're going to one of these 3 vendors?
We've seen more and more options evolve, it seems like, each year, right? So I think you're right in terms of the really big popular models right now, Google, OpenAI, Facebook. The Anthropic model looks really exciting. We're seeing more startups pop up that are doing these model trainings as well, like Adept, Inflection, AI21 Labs. There's also a community effort. If you look at like Hugging Face Big Science, where they're doing the training of their own large language models or foundation models, as well as Elucid, which is another kind of open source package that's out there for these models, which you can go download. But to your point here, Julia, there is just a handful right now. The way that I see it is a lot of the community is actually moving towards training these things. The main thing is getting all the data to actually pre-train these models. The model architecture itself is pretty well known and commoditized at this point. And my belief is that these models will become more and more commoditized over time as more and more researchers are going in and pulling in these large swaths of data to train on these things. But AGI in particular, so like the really ambitious, broad general problem, I still think will be contained to, the companies that have the financial resources to embark on these really expensive pre-training endeavors.
Yeah, you need really deep pockets to get to where they are. So the ones that you mentioned, Facebook, Google, OpenAI, they're set up differently than the average startup to be able to take on this endeavor of AGI. And it's really fascinating to see how OpenAI has become what it is today. They were started in 2015 as a nonprofit. They were seeded by some big named backers with the intention not to make money, but instead to just solve really hard research problems or the AGI problems. And it wasn't until more recently in 2019 that they switched their DNA to be this capped profit. So for those that haven't been following along, like the investors can only make 100x their returns, and then the rest of that profit goes back into the foundation to help fulfill this mission of bringing AGI to the world. And so this structure, coupled with really smart people and really deep pockets, enabled a technology to be successful in where it is today. But it feels like that recipe is not easily replicable, and it's a very once in a moment type situation. Would you all agree there? Or what was the magic of OpenAI to getting to where it is today?
Well, I would be interested to hear what Chris thinks about this, but I think OpenAI really hit on this period of time in AI where we started to see bigger equals better in terms of more and more parameters, results in better and better performance. And because they were able to raise a substantial amount of funding, they were able to just put that directly into training bigger and bigger models from scratch. And that's what, led to ChatGPT being what it is. What I'm going to be interested to see is how long this sort of bigger equals better trend sustains. And if we ever reach a point where by the time we have models with trillions of parameters and, it's verging on tens of trillions, are we ever going to see it plateau? But that's where I would be interested to hear what Chris thinks about that as well.
I agree with you 100%, Sarah. I think, these training of models from scratch, bigger and bigger, and also just very patient investors that were largely investing on the more research kind of nonprofit side at the beginning, bought them a lot of time, right? And flexibility to do this training that Sarah was talking about. And then, of course, there's this conflation of all these things that happen in the ML community with attention is all you need, and all these things kind of matching up at the same time that resulted in this really interesting output that we have now around these GPT models.
Yeah, it certainly helps when Microsoft gives you a $10 billion investment to continue in your efforts.
On the Microsoft thing too, I think one of the really interesting things there as well is, with having access to GitHub data and kind of the Codex model and learning all this, code data that they have in there has been an interesting thing, I think, in terms of feeding that into GPT and then making them much better at these generative problems for coding in particular.
I think all of us are long on this kind of set of technologies, and we're excited about the applications. And we'll probably get to the applications soon. But I think it's at least worth exploring one challenge that is frequently levied at large language models, which is that they don't reason symbolically. They don't actually have the ability to evaluate truth statements. And it's very strange as a human to interact via natural language with a system that produces correct sounding answers, and sometimes actually correct answers, but sometimes just correct sounding answers. And to realize that the process whereby this system is coming to its response to you is not akin to the process that you are using to evaluate the truthfulness or falsehood of this statement. So I think that often gets glossed over. Here's the other part of this question. I was recently reading an article where some properties of large language models are kind of emergent at a certain scale. And this is where this bigger equals better argument comes at. I don't even remember the capabilities specifically, but you could see that on certain capabilities, the line was essentially flat, and then the models had a certain size and it's just bam, went straight up. And no one has been able to predict to this point when new properties will kind of emerge from the model. Anyway, are we on a trajectory that converges towards models like this being able to evaluate truthfulness? Or are we always just converging towards just most plausible?
Yeah, happy to start here. So I think
it's almost like a philosophical question. I don't even know how good of an answer is there to this question.
Well, it's not clear there is a complete answer, right? But I'm always happy to give you my take on it nonetheless. I think the way that these models that I view them, at least at a high level right now, is that they're really just the smartest autocomplete functions that you've ever seen. So as you said, Tristan, they're not actually reasoning so much about truth, although you could then make a hop back and say what version of ML or AI was actually reasoning about versions of truth, although there's different arguments that can be made if you have labeled data, et cetera, and things of that nature. So I think, again, where I view these right now are great starting points, but the human still needs to be in the loop on a lot of the tasks that are going to be automated or accelerated on top of these right now. We have a long ways to go in terms of, is this actually outputting something that we deem to be truthful? One thing that you can do right now, and this kind of alludes back to what I was talking about before, though, is use these models as kind of a kickstart into the problem. So it seems plausible, as you were saying, but might not be the truth, Tristan. And then use a human in the loop to establish what truth is for this particular problem. So effectively here, what I'm talking about is providing some data labeling, which you can then use to continuously learn over these foundation models. And then you have that source of truth and you can tell how well you are performing against that source of truth. But out of the box, I think we still have a really long ways to go in terms of putting up these guardrails and making everyone really comfortable with the answers that are coming back from them. I don't know, maybe Sarah has a different perspective here, though.
Yeah, I definitely agree, especially about with these generative AI models. I mean, with ChatGPT, for example, I mean, I know that there is a reinforcement learning component to ChatGPT, but I really like the analogy about, it's the best autocorrect you've ever seen. You can call it whatever you want, a stochastic parrot, just next word prediction. I kind of like the analogy. I actually used to do improv for a couple years. And to me, it's actually very similar to working with an improviser because, what they teach you actually at Upright Citizens Brigade is whatever scene you're in, just generate words that make it seem like you're in that scene. If you have to pretend to be a doctor, you don't have to read medical textbooks. Just kind of regurgitate off the top of your head something that sounds like a doctor. I think that's very similar to my experience working with it. I think one thing that I'm going to be curious to see is how do we solve this accuracy problem? The human in the loop workflow, I definitely agree that that's a very effective technique, especially when the output is, important, like it needs to be correct, or it won't be usable. But I am wondering if, it's sort of like, will we continue with the generative AI models and we just build in maybe extra steps to the decoding where, the model itself is able to do its own sort of quality check? Or are we going to start combining them with, other types of models? Like, will the reinforcement learning component get stronger and stronger, or will they be fused together in a different way that helps it kind of self-correct? That's something that I'm going to be very interested to see.
So one of the most challenging things that I think we're going to have to figure out when it comes to data is like a very precise work, right? We ask very precise questions about what do we mean by most popular article of clothing sold this week? What does this week mean? What does most popular mean? What does clothing mean? Does that include shoes? I don't know. Coming up with an example, but we're very precise in how we do data work. And if you work with a data analyst, there's always like 10 follow-up questions because the way that people speak within a company often is far less precise than you need to create a SQL query that comes up with the right answer. And I'm really curious about how we're going to translate some of the human speech to getting correct, precise data questions answered. And I think there's like some very famous gotchas examples on the web where you ask ChatGPT to do simple multiplication and it fails, where it's like, well, actually a middle schooler or a lower schooler can answer these questions, but yet ChatGPT falls short here. So how do we get to something that's so imperfect like speech to something that's has a right answer like data?
Well, this is where I think the application layer is actually a really relevant piece of this whole ecosystem to talk about. It's one thing to build models that can do next word prediction and, be, the world's best autocomplete and, generate stuff. But in terms of what you actually do with that output, I think the leaders in that are those that are building applications that can add on more actually to the user interface and user experience, to be able to build out more of a workflow, like you were saying, to try to use this generative piece to lead the, whoever it is asking the questions to the correct answer.
Yeah, I agree with what Sarah said 100%. I think the UI UX and embedding in the workflow is a massive piece of this puzzle that we just laid out here. I also a slightly more, I guess, daring viewpoint as well is, I do believe these foundation models will continue to get commoditized over time. And so we're in this world right now where it's one size fits all, right? Everyone's calling OpenAI GPT-3 or these handful of other models that we have out there. As the trend kind of continues here and these things get more and more commoditized, I believe one world that we could live in the future is where everyone has personalized foundation models, sitting on their phone, their desktop, or inside of their organization, where it can then tune and learn the behavior of this organization such that I know how, I write code at enterprise XYZ, and that's different than different enterprises that we might be working with. So agree with Sarah 100%. I think there's two components of this. One massive one right now is UI UX and making sure that you have the right guardrails and embedded in the workflows there. The other longer term, I believe, is that this ML can be personalized and foundation models can really be personalized to organizations and even individuals over time to learn and adapt to the behavior that's important to that person or organization.
That's so interesting. You take the internal Slack or Teams history of a company and all of a sudden you get a model that converses in a way that the company, GitHub assets, that's a really neat idea.
Right. Or even look at the DBT code, right, inside of that organization. How are we defining revenue in this organization? It might be different than, another organization that you're working with. And then so that type of personalization is really interesting over time, especially as we continue to advance both on the hardware side and the machine learning side for these foundation models.
When we look at different ways that this technology can be applied, whether it be code gen, which we mentioned, where we're taking, structured code and trying to generate correct new code out of just having some context versus speech or image recognition, are these different classifications of problems? Are they equally hard to solve? Or is there something about, code, which is fairly structured? You have to get a software to compile and for a computer to understand it. Is that an easier problem to solve?
Again, I think with the improviser analogy, when it comes to text, there are some applications that are pretty easy, low barriers to entry for text generation where, say you're like, just generate 10 pieces of marketing copy, for example. There's no real right or wrong answer. It's more about just generate some things and the probability that one of those generations is going to be something you like is pretty high. So I think that sort of application has a pretty low barrier to entry. I think the same goes for image generation or even like music generation. If y'all have seen Refusion, or now Google has also a music generator. It's pretty cool. But I think it's a lot harder if there's only a right or wrong answer, and it's a lot more specified, a lot more quantified, what's right and what's wrong. That, I would say, has probably the highest barrier to entry out of any of these applications.
I agree with Sarah 100%. It goes back to one of the things that Tristan brought up as well. Like, there is a truth in code, and it's not clear if it's always, emitting truth from these models. So it's either, runnable or not, right, to a certain extent. And so there is a higher bar for code. And we actually have a lot of really interesting experiments and some research that we'll be releasing in the upcoming months here that show, just compared to actually some of the previous state-of-the-art techniques for text to SQL. So just taking natural language and generating SQL statements from that. If you just rely on, OpenAI out of the box without any kind of sophisticated demonstration engine or prompting engine underneath this, you can get pretty significant gaps from where the state-of-the-art, the specialized models are for that text to SQL right now. So there's this whole kind of gap that needs to be covered there in terms of how do you come back? How do you get the personalization? And there's a ton of interesting infrastructure challenges on this end too, because you often want to look at the data, understand the schemas and the data models inside of these organizations. And you don't want to do that right on the one size fits all model. There's interesting gaps and areas to explore here when you're looking at just this code generation piece, even though Codex has taken us, an amazing part of the way here thus far.
So there's text to SQL, obviously being able to ask questions of your data and turning that into a structured query that your warehouse can run. There's data prep work. There's maybe prediction work. What are some of the tasks that you both are focused on at your respective companies that will be a whole lot easier when we introduce generative AI into data work?
So we're working on two main things. at Number Station right now, although the vision and scope that we want to go after long-term is much broader across the modern data stack. And really right now, actually, interestingly for this podcast, it's all built on top of dbt. So we're always emitting dbt transformations. It's just how can we accelerate those analytics engineers that are out there right now, as well as eliminate some of this bifurcation that occurs with data science teams inside of these organizations. So the two things that we have right now are these custom text to SQL models and techniques that'll learn over your dbt scripts that you already have inside of your organization, as well as your data models and data that you have inside of your organization to help you write faster dbt code in the future. And then the second thing is right now, AI is all locked up on the data science teams. And these foundation models make it really easy for anyone to do something like a simple classification or sentiment analysis. And sometimes you might want to do that inside of your data transformations. So what we're doing right now as well is bringing these AI techniques. We're not claiming that you'd want to do something like, make a lending decision inside of dbt. But for something simple, like I have a bunch of text and there's customer reviews, and I would like to extract something from this or put the sentiment in another column. We're bringing these really small shippable models, starting from foundation models that can then be deployed using dbt and then something like Snowflake external functions or Redshift external functions. So the two high-level things are accelerating that writing of dbt code right now, and then bringing AI capabilities and democratizing that to this group of analytics engineers.
Yeah. And so for Seek, our focus is also on SQL generation. Our focus is on providing a natural language interface to anybody in an organization, whether they know SQL or not, and allowing them to just ask questions that they'd normally ask to, the data team and be able to get results more quickly. And also on the back end, help the data team, just be more productive in overseeing the generation of these answers.
So data teams are notoriously always inundated with data questions, and there's always bottlenecks there where the organization would love to have data to help solve a problem or aid with a decision, but there's often not enough hours in the day for data teams to help with all of these tasks. So do you expect that the future will look like extremely productive or 10x? Everyone can be a 10x analytics engineer, a data analyst, or a data engineer? Or will the role of the data team shift more fundamentally?
Well, just speaking from my personal experience being a data scientist, I always wish I had more time to focus on things that only I could do for the business. There were a lot of problems that I really wanted to work on that I was really excited about because I was like, if I can just figure out this tough problem, I can help my business make a lot of money in a significant way, or save a lot of money based on, the analysis that I wanted to be doing. And so our vision is that, we'll actually allow data teams to work on just more meaningful tasks. That's kind of our tagline is seek what matters. Focus on the things that matter. And that's the thing that used to frustrate me so much was I just wanted the answer, and so for Seek's interface, we're something that anybody can use, including the data team. And if you just want an answer, like I want this insight so I can get it quickly and make a decision and then go deeper into my research. That's what we're providing that, it's just, I don't think people understand how kind of old fashioned and tedious we're going to look back and be like, wow, remember those days where, I had to spend like 3 hours writing one SQL query so I could make one very small decision in my research. So I think this is going to unlock a lot of productivity in that respect for sure.
I think that this is probably the most interesting change that data professionals could see from this technology. How many Substack posts have I read over the years that talk about how to enable self-service, how to get business stakeholders to be able to take ownership of the iterative question answer process? And I don't know, it's like every 10th Substack post in the data space is probably about this topic in some way, shape, or form. And I feel like it is hard to imagine what the world looks like if that problem actually gets solved. And I think that this is one of the better shots on goal that we have at solving it for real. I mean, the first time that somebody that I worked for asked me to create a natural language interface to a data set was literally in 2001. It's just like a thing that people want. And I think it's a little bit of a mini singularity. It's just like very hard to see to the other side of like what happens if that exists, because so many things about our jobs as data professionals will be different if we were not constantly trying to solve the problem of like getting the insights that are in our brains into the brains of everybody responsible for making decisions in the company.
I agree 100% with what Sarah said as well in terms of, freeing people up to focus on what matters most for the enterprise. And just to riff off of what you were saying, Tristan, I think in the short term, something that I'd like to see as well as long term is just less of things being thrown over the wall and communication gaps between data analysts, data engineers, and data scientists. And if we have this one piece of technology that everyone can kind of center and anchor around, I believe there could be much higher productivity across organizations by having those teams kind of aligned on, common knowledge base or common foundation model that they're running across it. So that's one of the things I'm most excited about as well. In addition to, of course, just freeing people up to focus on what matters most for the business.
Can I ask a potentially spicy follow-up question here? Let's say that it is true that the interactive experience of using natural language to interface with data is important. Do you think that it is better to surface that type of functionality in kind of greenfield purpose-built tools? Or do you think that there are research departments inside of Microsoft and Salesforce that are like extending Power BI and Tableau and other, like, okay, maybe you first ask the question in natural language, you kind of get a data set back and maybe a default chart, but then maybe you actually want the standard Power BI experience of like editing it from there. I actually really don't know. I'm curious if either of you have thoughts here.
From my perspective, people might be comfortable inside of existing tools today. This is one of our big decisions to build on top of DBT and just make it as easy as possible for DBT users to have AI capabilities, as well as a way to accelerate what they're already doing. So I think there's a huge thing here. And the spicy question as well is like, okay, if it's just UI UX that we talked about before, what's preventing DBT or Power BI or whatever company, right, from just going in and building that UI UX? So one of the things that we anchor on really hard at NumberStation, again, is the custom fine tuning and training of these foundation models for your organization and for your particular task when you're ready to deploy it. So it's like two things. It's right. It's the UI and UX, but also what is the technology you're using underneath and what are the ML techniques that you have that are powering the system that you're providing? And is there some novel aspects to that? And that's kind of how we approach it from the NumberStation side.
I totally think that we're going to see like Salesforce and all the tools try to offer a solution. They've been doing this for years because the AI is not new and NLP is not new. Like there's Salesforce Einstein and there's Zendesk has their like automated AI support chat companies. I saw Intercom announced one today on using ChatGPT to help make recommendations.
That was fast. Wow, that's impressive.
Yeah, no, they're turning it around because it's like, if it works, this so clearly must be the future. And I put a big if it works because the edge cases has always failed us in the past and quality has always not been where it needs. And people have been burned and given up and said, oh, I'll do the manual, more expensive thing because I can't have people with the wrong data or I can't have the wrong support responses. It's a problem for my brand or for my mission or whatever it is. So there's a big if there. I do think that it will be very hard for the biggest companies to get it right because it will always be a like feature or a side thing for them that they don't put enough investment in. And it is quality here that's going to make all the difference. And so I keep thinking back to Zoom. There were a million video conferencing companies before Zoom existed. And everyone was like, well, why do I need Zoom? There was like Blue Jeans and Google and they had
Skype.
Citrix had
GoToMeeting.
Yeah, GoToMeeting, which was Citrix's offering. And I think in this case, like quality and that interface between how do you work with the users at the company are just going to be so important that it's going to require a different level of investment and focus to nail the experience. And the difference between excellent and good are going to be very different, where it'll be hard for people to just open up Looker and make that a possible experience.
I think I definitely agree with that, if you've already built software that, you've identified the customers that get value out of the software you've built without AI thus far, it is probably going to be a challenge to really integrate generative AI. I mean, it's not a magic bullet. It's something that can increase the value that you're already giving your customers. But what I think is really interesting about the startups in this space is we have the opportunity to build from the ground up. One of our investors, Sarah Gawa from Conviction, has this phrase, software 3.0, software that's being built from the ground up with AI, in its very DNA. I also think, I spent a lot of time doing time series analysis, in financial markets. And it's like, you can never predict what's going to happen, 5 years down the road. You can be pretty good at predicting things in the short term, but there are always going to be these mutations in the startup world and also across companies that are working with this technology that might be kind of random, where people discover, wow, this is a killer use case that I would have never thought of from first principles. And I think we're just going to see some of that. And there's probably some things that we don't even know that it's coming. But when it comes out, it's going to be, another step function.
We have to wrap up. We ask this to all our guests, but looking 10 years out, what do you hope will be true for the data industry?
Yeah, so I think I already hit on kind of the 2 points that were on my mind there. But one is eliminating these communication mishaps across teams that occur inside of data organizations. And then I think Sarah said this beautifully earlier as well, but really just freeing up data workers and data practitioners to spend time on insight generations and things that matter for the business, not these nasty cleaning preparation problems where they spend a lot of their time today.
Yeah, and I would say what I would like to see is I really hope that we continue seeing adoption of DBT because...
Us too.
I'm not just saying that. I really want to see the semantic layer just continue to get more and more adoption and see the natural language interface really get more adoption because that'll mean that working with data is just more and more abstracted. And like I kind of said earlier, it'll be a thing of the past. That would be my dream. The old data scientist in me before starting Seek would be really happy to see tools come out where it's just, you don't have to spend, 3 hours writing a SQL query anymore.
Hell yeah. Chris and Sarah, thanks. This has been a very fun excuse for Julia and me to get to talk about large language models, ChatGPT, and how it's going to affect all of us. So I'm excited to hear how this episode lands because every time I write about this in the Analytics Engineering Roundup, I'm just like, are people sick of hearing about this? Is this like all that anyone ever talks about? So if you're listening to this and you thought this was a fun episode, fun topic, definitely give us some feedback. I know that there's some other folks who have thoughts in this space too. I think it's really important. Thanks a lot for joining us.
Thank you so much for having us.
Yeah, thank you so much.
The Analytics Engineering Podcast is sponsored by DBT Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? Email us at podcast@dbtlabs.com. Our producers are Jeff Fox and David Krevitt. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.